Hello, second grade. It's me again, and we are back into arrays today. I am so excited to continue this work with you. Let's take a peek at our learning target and see how it's just a hair different than it was yesterday. I can draw an array and write an equation to find the total number of items in the array. Very similar to what we did yesterday. What do you notice is a little different? Yesterday we built with our tiles. Today we're going to draw. Okay, so we're going to take it one step farther than we did yesterday. You might build first, and then you're going to draw in your math notebook to help you really see that array and have it on paper in front of you. I can draw an array. Now remember, what is an array? It's a set of objects arranged or organized into equal columns and rows. Remember, rows are going horizontally, columns are going vertically, okay? Rows, columns, very good. And those have to be equal or the same. That means that each row has the same number in it. Each column has to have the same number in it. But then we're gonna represent or write an equation because we want to, or a number sentence, because we want to find the total number of items in the array. And we did that yesterday with our hats problem. Remember, our friend had this shelf of hats and he had them organized, but he didn't know how many he had all together. And we had to find that out by writing an equation. We even found out was there one equation that helped you get it? You guys came up with two different number sentences to match his array. And we're going to see that same work come up again today. Let's take a peek at our first problem. Mike put some stickers into an array. Now his stickers are star stickers. They're just beautiful stars. Each row of his array has 5 stickers in them. And each column has 4. How many stickers does Mike have? Let's go back and reread that again. He has some stickers into an array, okay? Each row has 5 stickers. And each column has 4 stickers. How many stickers does Mike have? Now, this is where I'm going to go back to our work from yesterday, and you can see this right here, okay? You can see our group of 8 that we built, right? Now, Mike's stickers each row has 5, right? But each column only has 4. So when we look at this, 2 rows of 4, okay? Kind of like his rows of 5, okay? But then we had 4 columns of 2. And what do you notice about those numbers? They're the same, aren't they? Right? They're just flip-flops. So 2 rows of 4 or 4 rows of 2. Let's think back to the work from today. He has 5 rows of 5 and columns of 4. So how can we use our picture, you might even build first, to help you show Mike's stickers? You may go ahead and begin. I'm going to ask you some questions while you work. So how many rows are you making? Well, why are you only doing 4? It says 5 on the rows. Oh, he said each row only has 5 in it. So how many? Okay, so you have a row of 5. So how do you know that you only have 4 rows? Because there's 4 in each column. Oh, so where's your column here? So there's 4 in this column, 4 in this column. How many columns do you have? How could you, that's a fantastic array. How do you know how many he has altogether? So if he has, what would your equation be to match that work? So how are you going to find the total? That's a lot of add-ins. Ooh, I can't wait to see what you're doing to add those together. I love your array. Where are your rows in this array? How many rows do you have? How do you know there's only that? How do you know there's that many rows? Oh, because there's 4 columns, or 4 in each column, and so there's 4. Ah, all right. And your equation looks different than another, friends. Will you share that equation with us? All right, friends, a lot of us built before we drew, but I'm going to go ahead and draw what our friends did. So tell me what you said you know. Okay, so you did 1 row of 5 first. Did anybody else do that 1 row of 5 first? 1, 2, 3, 4, 5. Why did you do that 1 row of 5 first? I think I'll do my orange marker so you can see it a little bit better. There's my star stickers, okay? Why 1 row of 5? Okay, because it's something you know, right? It's kind of like in our other word problems that we've done before. What do we know? We know that each row has 5 stickers, so there's 1 row. So now what are you going to do? Well, you're going to build a column, okay? And so when you're building your column, where did you start? Okay, in that first column. All right, and how many did you draw in that first column? Why did you draw 4 in that first column? Because each column has 4 stickers. So there's your first row, row 1, and this is our column 1. So this column only has 4 in there. So then what do we need to do? So am I going to draw a 5th one here? No, I only have 4. I only have 4 in each column, so I've got to just fill that in. Because what is an array? A set of objects that has the same number in each row, or equal rows and equal columns. So are my rows equal so far? Yes. Oof, this is hard thinking. Each row has 5. Each column has 4. So I'm going to underline this for me so I don't forget that. And then those of you at home can use that to help you as well. Row 5, column 4. Row, 4 rows of 5. Each column has 4. Is that what our array should look like? Give me a wiggle waggle if you did that same array. Either you built it and then drew it, or just drew it. Okay, so now we need to write an equation to find the total numbers. I don't know how many we have. What was your equation? 4 plus 4 plus 4 plus 4. And how does that match that array? You were adding your columns together. 4 plus 4 plus 4 plus 4 plus 4, okay? You were adding your columns. So how did you find that total? Okay, so you said that's 8, that's 8, that's 16. Okay, so 8 plus 8 equals 16. And then 17, 18, 19, 20. You still had to add that last 4 in there to get that 20. Who else wrote that same equation? Okay, somebody else did another equation. Could you share with me what equation you did? Tell me why you wrote 5 plus 5 plus 5 plus 5. You were looking at your rows, 5, 5, 5, and 5. And why did you choose your rows to add? Oh, okay. 5, 10, 15, 20. You can skip count. 5, 10, 15, 20. Anybody else skip count those? Okay. How else could you find the total? 10 and 10. And what does 10 plus 10 equal? 20. Now, friends, what do you notice about these two equations, or how does that connect, and how does that connect with our array? What do you notice about them? So they have the same total or sum. What else do you notice? I'm adding 5 4s. But I'm only adding 4 5s. Wait a second. 5 4s, 4 5s. 5 columns of 4, 4 rows of 5. Those columns and rows are very tricky, aren't they? Do they kind of give us a clue as to how we can solve these problems? They can, and they are, right? So we can use these two pieces to help us know. 4 plus 4 plus 4 plus 4 plus 4. So when we have 5 columns, we have to add that 4 5 times. But here we only had to add our add our 5s 4 times. 1, 2, 3, 4. They both equal 20. Let's solve our next problem and see if we see the same pattern. Okay. In a game, players put pieces in 3 columns. Each column holds 5 pieces. How many pieces fill these columns? Really what we want to know is how many pieces are in this array. If in this game, players are putting pieces in 3 columns and each column holds 5 pieces, how many pieces fill these columns? Go ahead and take a minute and show or draw that array to match this problem. You may go ahead and begin. She can just leave. How many columns did you draw? 3, okay. And how many are in each column? How many are there all together? That was fast. How'd you know? I love how you're skip counting. What equation could you write to match this array? Your friend right next to you wrote a different equation. How can you both have a different equation to match the exact same array? Can you guys talk about that for just a minute? How can you find your total? So when you're adding your 3's together, what are you using to help you? Okay, making some of those doubles. All right, and then what was your total? All right, friends, coming together in 5 4. Remember, if you're not done, you can always pause me and resume me when you're ready. 3 2 1, and done. All right, what does our picture look like, my friends? I'm gonna choose a different color. I just like to change it up a little bit. 3 columns. 1, 2, 3. Column 1, column 2, column 3. Did you all start that way? I saw you drawing that out there super quick. How many do we have in each column? 1, 2, 3, 4, 5, right? How about the next one? How do I know that I'm just going to do the same thing for each column? Because an array has equal columns and equal rows. So if we have 3 columns, how many rows do we, or how many do we have in each column? Okay, 3 columns of 5. Did I make that up? No, it's right there in the story. 3 columns, each column holds 5 pieces. So how many rows do I have? How could this help me figure out how many rows I have? Yes, I have 5 rows of 3. How did you know that? Every time, those 2 numbers just flip-flop, right? If I have 3 columns of 5, then I am going to have 5 rows of 3. 1, 2, 3, 4, 5, and there's 3 in each row. Very good. Now, I have two different equations that friends wrote, and I'm very curious to talk with you all about how they both can be an equation to match this array. So one of my friends wrote 5 plus 5 plus 5 equals My other friend wrote 3 plus 3 plus 3 plus 3 plus 3 equals, I don't know, 2, 4, 5. Okay. What? How can both of these equations, what were they thinking? How can both of those equations match this array? What do you think? Okay, so 3 rows of 5, or 3 columns of 5, 1, 2, 3 columns of 5. And what does that equal? How could you know that so quickly? And so many of you were doing that. Just boom, 15. How do we know? 5, 10, 15. Just in a snap. Skip counting. 5, 10, 15. Okay? So this one was thinking more about the columns. The 3 columns of 5. There's 3 groups of 5. How about our 3s? Where are those coming from? 3 here, 3 here, 3 here, 3 here, 3 here. And what are these pieces that are going horizontally in an array? They're those rows, and there's 5 rows of 3. So we have row 1, row 2, row 3, row 4, row 5, and they have 3 in each of those. So how do we figure out the sum of those those numbers? Oh, no, it's not 3. 3 and 3 is 6. And what did you do? Another 3 plus 3 is 6, and that equals what? 12. Okay, and then 3 more than 12 is 15. Now you might know that in a snap. Somebody told me, well, 2 and 3 equals 5, so 12 plus 3 equals 15. You're looking at that ones place. But some of you said 12, 13, 14, 15, and counted on. Both of those are great ways to show how we're solving these problems. Now, can I ask you a question? If I wanted to add another column, okay, I'm going to do this in a little different color so you can see what I'm thinking. If I wanted to add another column, how many more pieces would I need? If I wanted to add one more column, how many pieces would I need? Thumbs in front of your tummies when you think you know. How many more would I need if I wanted to add another column? Who else said 5? Why 5? They need to be equal. Call your an equal number. We should have 5 more in that column because each column has 5. Very good thinking, friends. You have an exit ticket today. It's about Reba. Reba has rows of flowers in her garden. Each row has the same number of flowers, duh, because it's an array, right? But if each row has the same number of flowers, she says that that is the equation that matches her work. That there are 8 plus 8 plus 8 equals 24 flowers. I want you to draw the array to match this work. Come on, hold that up to you one more time. Reba has rows of flowers in her garden. Each row has the same number of flowers. Reba says that there are 8 plus 8 plus 8 equals 24 flowers. Draw an array that shows Reba's flowers, okay? And, well, that's her equation. So she gave you the equation. You have to write the array to match it. I cannot wait to see the thinking that you're showing. And tomorrow we're going to make it one step trickier as we think more about arrays and how those numbers work together. Happy solving, friends. See you tomorrow.